So squares have some pretty simple properties, right? For one thing, they have four sides. Um, for another thing, they've got the sides are equal in length. And then finally, the interior angles are all 90-degree angles. They're all right angles, right? So squares not that exciting, right? But they kind of are exciting. Um, and what we'll do in this exercise is to use the properties of squares to figure out some information about this situation which uses a square, right? So we'll just answer some questions about it, which will force us to derive information based on the fact that this is a square. So A, B, C, D is a square. So that's good. So now we know the properties of squares apply. Like that angle is a 90-degree angle, that angle is a 90-degree angle, etc. Um, be careful. You might have something that is drawn so that it looks just like a square or it looks very close to a square. But if you don't know for a fact that it is a square, you can't assume that it is. You have to either be told it is or be able to prove that it is before you, um, proceed on the basis that it's a square. Because I don't know, maybe the angles are, one of the angles is 89 degrees. Well, no, it's no longer a square. Um, so yeah. All right. Well, we know it's a square, so it's a given. So let's proceed and kind of fill out this information and answer these questions that I've posed for us using the properties of squares. So AB is equal to 10. AB. So let's draw that on there. 10. 10 what? I don't know. We'll say 10 kilometers, but I'm not going to write the units. It's 10. Okay. AB is 10. All right. Line segment DE bisects, I think that's supposed to be a B, BC. So to bisect something means to cut it into two equal halves. So BC, so B to E is equal in length to E to C, basically, is what that is saying. So what does DE equal? Well, wait a minute. I mean, we just know we know it bisects this line segment. But how are we going to figure that out? Well, let's apply what we know. So if AB is 10, then BC is also 10 because the sides of a square are all equal in length. So if BC is 10 and DE cuts BC exactly in half into two equal halves, then BE is 5 and EC is 5. 5 plus 5 is 10, right? Okay. Well, what else do we know? We want to figure out this length. Um, well, we know if AB is 10, then DC is 10. 10. And for that matter, AD is also 10, of course. Um, well, we also know that this is a right angle, right? That's a property of squares. The angles on the inside are right angles, they're 90-degree angles. So, actually, DEC is a right triangle. So let me just draw that over here. This is a bad illustration, but what we want to get is DE, length of DE, which is, yeah, this is what we want. So that is the hypotenuse of a right triangle we have just discovered. Um, so we know this side length. We know that side length. We don't know this. But we do know from the Pythagorean theorem that you take one of the shorter side lengths and square it, add it to one of the other shorter side lengths squared. That is equal to the square of the hypotenuse, the longest side length. So a squared plus b squared equals c squared. So we know that 5 squared, not really into this color right now. Yeah. 5 squared plus 10 squared equals c squared. C is actually this DE line segment. So 5 squared is 25, 10 squared is 100. 25 plus 100 is 125 equals c squared. So C would be the square root of 125. Square root both sides. And let's just simplify that. 125 is 25 times 5, right? 25 times 4 is 100, plus another 25 is 125. The square root of 25 is just 5, so we could call this 5 square root of 5. We got that 5 left. So DE is 5 square root of 5. Yep, okay, so that answers this question. Alright, the measure of angle EAB is 26.6 degrees. Okay. EAB, 26.6 degrees. Measure of angle CAE, sorry, I think that's supposed to be DAE. Measure of angle DAE. I switched some things around. Forgot that one. Sorry about that. DAE is 2x. Alright. What does x equal? Well, again, due to the properties of a square, we know that this angle, the total angle here, DAB, is equal to 90 degrees. And it's made up of these two smaller angles, 26.6 degrees and 2x degrees. So we could just write a simple equation here. 2x degrees plus 26.6 degrees is equal to 90 degrees. Then we can solve for x. Subtract 26.6 from both sides. So what is that? 10 minus 6 is 4. Borrow, then carry, and that's 3. Just going old school. 63.4 degrees. Does that make sense? Yeah, that makes sense. Okay, so 2x degrees equals that, 63.4. So I could divide both sides by 2. And I don't know, since we're going old school, I'll just do that by hand too, just to show you my division skills. 2 goes into 6 3 times. 3 times 2 is 6. Got nothing left over. Pull down the 3. 2 goes into 3 one time. Times 2 is 1. Got 1 left over. Pull down the 4. 2 goes into 14 7 times. 2 times 7 is 14. So there's 0 remainder. So x is 31.7 degrees. Alright. Well, what's the measure of angle ADE? ADE. Well, let's see. We know that, let's see here. We know that this angle is 31.7 times 2, which is 63.4. Okay, so is this 63.4 degrees? Alright, now, we've got to do a little bit more reasoning here based on the fact that it's a square. So this side length is 5 square root of 5. Well, AE is also 5 square root of 5. Why? Because we could do the same right triangle business over here, you know, with side length 10, side length 5. Right? So we know this is 5 square root of 5. Well, so then that makes this AED a isosceles triangle. So just two sides that have the same length, which means that this measurement is also 63.4 degrees. Yeah. So the angles of a triangle, the interior angles of a triangle, all add up to 180 degrees. So we call that y. And that's what we want to figure out. ADE. No, we just figured out ADD. ADE. All right. That was easier than I thought. Anyway, if you wanted to figure out this angle, AED, you would just add these two and subtract that from 180 because all three have to add up to 180. So measure ADE. ADE is also 63.4 because that's an isosceles triangle. All right, do we have any more questions here? Answer them all. So there's an example of we've got a fairly simple situation here that's based on a square, and we can reason using the properties of squares to figure out from the information that we have, plus information that's implicit in this being a square, we can reason to get all kinds of interesting information about this situation. All right, see ya.